This is a question from Csir Net December 19. It is from ordinary differential equation. Given question is that consider the eigenvalue problem 1 plus x to the power 4 y dashed power whole dashed plus lambda y equals to 0, where x belongs to open 0, 1 with the boundary conditions are y0 equals to 0, y1 plus 2 y dashed 1 equal to 0. Then which of the following statements are true? Number 1, all eigenvalues are negative, and second, all eigenvalues are positive. Third, there exists some negative eigenvalues and some positive eigenvalues. Fourth, there are no eigenvalues. Given differential equation is 1 plus x to the power 4 y dashed whole dashed plus lambda y equals to 0. Okay. Then what I am doing? Multiplying by y, multiplying by small y, and then integrating it from 0 to 1. Okay, we get 0 to 1, 1 plus x to the power 4 y dashed whole dashed y into dx. This is exactly equal to minus of lambda 0 to 1 y square into dx. We call it 1. Okay. Now again 0 to 1, 1 plus x to the power 4 y dashed whole dashed y dx. We will find the value of this integration by parts method. Okay. Take u as y and v as this term. Okay. Add a state that this is exactly equal to 0 to 1 y into d of 1 plus x to the power 4 y dashed. Okay, this is exactly this. Now we will apply by parts method on this integration value. Take y as u and d of this consider as v. Then this will give u into integration of v. This is d of 1 plus x to the power 4 y dashed minus y dashed, and this integration value will give x plus 1 plus x to the power 4 y dashed 0 to 1 into dx. Okay, this equal to y x to the 1 plus x to the power 4 y dashed interval as given as 0 to 1 minus 0 to 1 1 plus x to the power 4 into y dashed square dx. Okay. Since given boundary conditions are y at 0 equal to 0, so from this term we obtain that this equal to 2 into y1 into y dashed 1, and this term remain unchanged, equals to minus of 0, 1 0 to 1 1 plus x to the power 4 y dashed square into dx. Now given another boundary condition is that y of 1 plus 2 into y dashed 1, this equals to 0. From here we obtain that y dashed 1 is equal to minus half of y of 1. So the line 2y of 1 y dash 1 minus 0 to 1 1 plus x to the power 4 y dash square dx, this equals to minus y of 1 square minus 0 to 1 1 plus x to the power 4 y dash square into dx. Now from 1, now see, it is, I called as 1. From here we see that y of 1 square plus 0 to 1 1 plus x to the power 4 y dash square dx, this equals to lambda into 0 to 1 y square dx. Since it is a square term, it is non-negative, okay, and here the integrand is also non-negative, and since it is a definite integral where f of x is greater, here this, if we consider this as f of x is greater or equal to 0, okay. So integration 0 to 1 f of x dx, this also must be greater or equal to 0. From this we obtain that LHS, left hand side, is greater or equal to 0. So this implies, since the right hand side is also lambda into 0 to 1 y square dx, here integrand is y square, which is non-negative, and it is a definite integral where the limiting value is from 0 to 1. So this integration value is also greater or equal to 0. From here we obtain that lambda is greater or equal to 0, okay. Since the LHS is greater or equal to 0 and this integral value is also greater or equal to 0, so lambda is also greater or equal to 0. Now see that if lambda equal to 0, then what will happen? Then this will imply then the LHS equals to 0. Since LHS contains sum of two non-negative terms, so if their sum is equals to 0, then they are separately 0. From here we obtain that y of 1 equal to 0 and 0 to 1 1 plus x to the power 4 into y dash square dx, this equal to 0, okay. Now from this we obtain that 1 plus x to the power 4 y dash square, from this we obtain that 1 plus x to the power 4 into y dash square is equals to 0, because this is non-negative and the integral value is 0. So the integrand equal to 0, and this gives us y dash equal to 0. Since x belongs to open 0, 1, so 1 plus x to the power 4 not equal to 0, and this will give us y is equal to c, okay. But since y at 1 equal to 0, therefore c also equals to 0, hence y is identically 0. Now observe that the given differential equation is a Sturm Liouville problem, okay. It is of the form Sturm Liouville problem, where we call an eigenvalue lambda exists if for it there exists a non-zero solution of the given differential equation. But see that here for lambda equal to 0, the differential equation has a trivial solution. So 0 cannot be eigenvalue. 0 cannot be an eigenvalue for this differential equation. Hence, all eigenvalues of this differential equation must be strictly greater 0. Okay, that is lambda here strictly greater 0. So right option is that all eigenvalues are positive. Hence option 2 is the right